Welcome to this video on composite functions, which means when one function is inside another function. So this is everything you need to know for composite functions, just these 3 steps. Here we've got one with a square root. Now we know that whatever's in the square root is likely to be the inner function. However, we don't like square roots when integrating, so we're going to use our exponents and roots rule. And that'll give us 4 divided by x to the power of 4 plus 1 all to the power of a half. But again, we still don't like having terms on the bottom of a fraction, so we can use our fractions and powers rule. And that would give us 4 multiplied by x to the power of 4 plus 1 to the power of negative a half. Now we're ready to integrate. So we can separate our inner and outer terms. Writing those out, the outer term is 4 multiplied by something to the power of negative a half. The inner term is whatever's inside these brackets here. So step 1 is we integrate the outer term, where we add 1 to the power, so it'll take us to positive a half, and divide by the new power, which is 1 half. And then step 2, we differentiate the inner function, and that's going to give us 4x cubed. Now for step 3, we divide the outer function by the inner function. So that gives us 4 multiplied by something to the power of a half, divided by our half from the outer fraction, and multiplied by whatever was from our inner fraction. Now again, we need to simplify because we can't have this squiggle in there, so that becomes 4 multiplied by whatever was originally inside those brackets. And a half multiplied by 4 simplifies down to 2. Now you could simplify that further to just be 2 over nothing, because 4 over 2 simplifies down to 2. Now a quick note before we move on, you can divide by a fraction here like we've done. However, it's almost always easier to multiply by the inverse of the fraction. So instead of dividing by 1 over 2, we could multiply by 2 divided by 1, which if we simplify would have given us 8 multiplied by something to the power of a half. And that's just much easier to deal with than fractions divided by fractions, and still would have given us the same number, because we would have divided by this 4 over here to get our 2. So multiplying by the opposite of a fraction is often the easier way to deal with powers of fractions. And of course you should always add c onto whatever you're integrating. Let's look at one more example. Here we have sine multiplied by e to the 2x. So first we separate out our inner and our outer function. Our inner function is whatever's inside the brackets, our outer function is whatever's left over. Step 1, we integrate the outer fraction, and we can look at our differentiation table to help us out. Now sine integrates back to cos, and that negative gets put on the other side. So sine something will integrate to negative cos something. Now step 2 is differentiating this outer function. So to do that, we differentiate whatever's on the top, that's 2, and then multiply by that differential. So that becomes 2e to the power of 2x. Then we do our third step, which is dividing the outer function by the inner function. And finally, we substitute whatever was originally in those brackets back into the brackets in here. And there's no other simplifications we need to do. We just need to add c. So this is everything you need to know for composite functions.